Welcome. My name is Tong. I'm a senior solutions architect from InterSystems. Today, I'm going to talk about the CDCs. No, that's not the Center for Disease Control. That's stands for Change Data Capture with InterSystems IRIS data platform. So what are the CDC challenges? I mean, the change data capture challenges. Since you have many data silos, right? Different data sources, different systems. So you may face some of these challenges. First, the data, they have to be replicated. So the replication will cause delays. And then during the replication, if the metadata or schema, they don't match, there's a mismatch, the replication will break down. So someone has to fix the schema or the metadata or the data itself. Then you also have data quality challenges. So that means maybe one data passed the validation rules in one system, system A, but by the time it replicates to system B, the system B's validation rule, or even on paper look the same, but it enforced more strictly or whatever the reason, it may fail the validation, right? So you have a data quality issue. Then they are also involved. So since we're talking about data quality or validation, so then we're talking about data transformation, because sometimes you have to transform data before you can apply the data from system A to system B. So now you have a new problem. It's the data lineage. So if you have one transaction or whatever, a customer account data record in system A is in this format, then when it arrives in system B, it's a different format, but you want to know what change, who performed that change, right? So this is a data lineage problem. And if you're in financial services, in the banking industry, the regulator want to see your data lineage. So it's a big deal. So that's an inherent nature of the challenge CDC will have. Then along with the data lineage, there's also data governance. So imagine you have in your system A, you have the set of data, then you have a set of users, roles, among others, and then you apply the permissions for certain users or certain roles can access certain portion of the data, or what kind of operation they can do. Do they have the read-write operations? Do they have the admin privilege? Do they have the read-only permission, among others? So you have full control, and hopefully you also have an audit trail. But once you replicate the data to another system, you lose that visibility or control. So that means how you kind of enforce the data governance, right? Then also there will be security concerns too. So you can do whatever you can within your system A, but if you have no control over system B, once you do the CDC replicate data there, then you have to rely on the system B to guarantee the data security, among others. So these are the main challenges CDC facing. I'm not telling you IRIS is going to solve all these challenges, because many of them are inherent to the CDCs, but I can tell you IRIS actually participate CDCs. And then I would share with you in some of these cases how we would overcome these kind of challenges and to meet our customers, to help our customers to meet their requirement. So actually, before we get into the business of CDC, I want to talk about the design philosophy of IRIS. Right? So I'm a senior solution architect from InterSystems. So I actually help my customer to design their mission-critical applications on top of IRIS data platform. So the first advice to my customer is just to avoid unnecessary data silos and data replication when possible. So that means I want you to collapse many layers of technology stack to a single layer, which IRIS offers you out of the box. So something traditionally you cannot do, such as on one side you want to do business transaction, process a lot of transactions. Imagine you are a bank, so you want to either you're a retail bank, a lot of checking, deposit, mortgage, application, whatsoever, business transaction, or if an investment bank, then all the stock trades and fixed income, foreign exchange, future options, you name it. But you typically have to replicate it to a secondary system for the analytical purpose. So typically, the secondary system is another relational database or data warehouse or even data lake. Nowadays, at least a few years ago, people tend to think that data lake was the silver bullet, so they can dump everything into data lake. Yes, but if you create different silos. But IRIS wants you to reduce these unnecessary silos. The IRIS can handle both of these work in a single place with a single copy of data, so you don't have to worry about it. But behind the scene, since I'm not asking you to go back to old days of the mainframe, right? The monolithic, it's just a big iron, one huge expensive box, and put everything, put all your eggs in one basket. No, not that way. So IRIS itself is very horizontal scalable. So you can add many data shards, data nodes, we call it, or you can add our cache node via our ECP distributed caching protocols. So that means inherently IRIS internally has the CDC challenge. So as I told you, yeah, we're facing the same challenge, but we solve that challenge for you transparently, so you don't have to worry about it. So internally, we're going to worry about how to synchronize data inside IRIS data platform, which we did, but you don't have to worry about it. So that's the first advice I give to any of my customers as how to build their system on IRIS. Reduce unnecessary silo. The IRIS can do more than just a single data store you have in your current infrastructure. But on the other hand, this topic, this session is about CDC, because there's other legitimate reasons you must do some sort of CDC, such as you have some legacy systems you cannot change, you have your partners, you have your customers, internal, external systems you have to interact with. Even in the era of the cloud computing, right? Everybody's deployed in the cloud. But in the cloud, you open the floodgates, and now you have many other data sources and tools you can use from the cloud vendors' native offerings, as well as all the third-party offerings available on the cloud. So you want to be able to do these CDCs in the cloud or on-prem. So typically, CDCs can be like a breakdown into these three categories. One is the SQL based, the other is message event based, and the last but not least is batch oriented. So I'm going to talk about all these three areas, how IRIS can help. Okay, let's get into it. So the first thing I want to talk about the SQL based CDCs, right? So what SQL based CDC is very simple. It's basically, typically you need some sort of replication software commercially. I think there's also open source version. So like Oracle Golden Gate, SAP Sybase Rep Server, among others. So IRIS just participate these SQL-based replication by providing very highly efficient and reliable IRIS drivers, XDBC drivers. Older generation of these SQL-based replication use ODBC. Guess what? IRIS has ODBC. Even we have ODBC on Linux. Okay, so how sophisticated we are. So you just need to set up our ODBC or JDBC drivers, and then we can start receiving messages, not messages, SQL statement from other data sources via the SQL-based replication. Then in terms of publishing what data change inside IRIS, again, using SQL, and we have a SQL gateway. So just like the Oracle Golden Gate web server, our SQL gateway actually can use Oracle's JDBC, ODBC driver, Sybase ODBC, JDBC driver, and we make connection to them. Then internally inside IRIS, either you build some sort of timestamp-based mechanism or a trigger-based mechanism. So timestamp-based mechanism is that basically in every table you want to participate the CDCs, you will create additional field which capture the timestamp of the record change, not the record created timestamp, but the timestamp change. So that's actually, these timestamps exist in many of the systems, including these banking systems. They already had the timestamp. Every time when a record was updated, that timestamp is recorded, right? So they already have time-based system. So then what you can do is that you can build a process. Typically, you don't want the process running constantly, so you will let it to basically sleep like for an interval, let's say 5 seconds, 10 seconds, or a minute, depends on your replication latency requirement. And then it will wake up and scan that particular table to see what are the timestamps since it went to sleep last time. So it will collect all these rows and then create the corresponding update insert statement to the other side. And the trigger based is that instead of looking at timestamp, you are going to put triggers on IRIS tables. So it's the after insert, after update, after delete. So again, when that trigger is fired, it will basically, it can basically call our SQL gateway to send the same statement to the whatever target you want it to replicate to. Here also I want to point out is that the trigger-based mechanism is the only way you can get almost near real time. But on the other hand, not necessary. Sometimes you still can have triggers. You can capture the change, but you can put it into internal IRIS queue. Then you let a background job to wake up at its own interval, just like it's scanning the timestamp change, but instead of just looking at the queue. So whenever you put the queue, it will send the SQL statement to the remote systems. So that's how IRIS can participate a SQL-based CDC. Let's look at the pros and cons of this approach. So first, you already heard me talk about like it's very easy to set up because it's used in the XDBC. And also it's easy to maintain. The point I want to make is that because it's all use SQL. So that means you can find the SQL developers, and then either some of them need to write the store procedures or to do the timestamp scan or do the triggers, but it's easy to maintain. And then I also point out that the trigger based is it's real time. It's near real time. As soon as the trigger is fired, and the same statement will be sent to the target, the other database. And then it's very mature. Yeah, it's been around for a long time. Then the limitations of SQL-based CDC is primarily this the schema on both sides must be the same. Okay, so if you have so many fields in in SQL source A or down the table, account table, you must have exactly the same schema in the other one, no matter which one is IRIS, which is Oracle. That's basically it's the same. You must be the same. And typically, you don't do a transformation for these SQL-based CDCs because it's just like the same statement. It's basically the same SQL statement. Whatever you apply to this guy, you want to apply to the other guy. So you typically don't do these transformations. Right? And then the other thing is that it's typical. It just keep on replicate these data, like SQL-based CDC, replicate the data. So everything you have here, it will end up with there. So there's no control. Once the data is replicated, you have no control who can access this replicate copy. So that's why many of the large organizations, especially these financial organizations, large banks that I deal with the most, they're very concerned to create these additional replication targets. And the data governance and security is, I think, the top reason. But last but not least, I want to talk about some of the limitations of SQL-based CDC is that they typically, because we're talking about relational SQL, right, old-fashioned SQL, they don't actually natively support many of the modern data types. And although you can store XML and JSON in SQL tables, but not in the native format unless you store them as blob. And last but not least, I want to highlight is this SQL Based CDC is actually it's old-fashioned, so it's a one-to-one. So you have to set up a replication target, and then you replicate to the others. Although many of the middleware can also do kind of broadcast, so it can do one-to-many. But it's typically it's not scalable. That's what I want to say. So now let's look at another type of CDC, which is messaging event-based. Actually, this is the most modern approach to CDC. And because, as I told you in previous slides, that the SQL in many cases is not enough, all kinds of limitations. But the messaging, streaming message, event processing, is already being used by many applications over the past decade. So it's mainstream. Many companies already have messaging infrastructure in place, event processing infrastructure in place, sometimes complex event processing, CDP in place. So when people have CDC problems, they say, hey, let's look at our messaging infrastructure, our event-based infrastructure. So they tend to use some sort of messaging bus, and then they do a subscription and publish, and against that bus on some topic. So there are some those legacy messaging systems. So I give you IBM MQ series. Then there's something like from Oracle, you can get the Java-based GMS. But nowadays, the hardest messaging bus is Kafka, right? So Kafka first is open source, then it's also embraced by AWS. There's also another commercial distro, Confluent, Kafka. So whatever messaging event process CDC you have, IRIS can always participate such CDCs. So IRIS can subscribe from any of these message bus, and also we can publish to these message bus. And because in these message event-based one key feature is that it's very flexible. The payload can be very flexible. It's not as rigid as the SQL-based CDC. So that means by that nature, the transformation must be performed, because since your payload, the message payload, is so flexible, so you must transform. So IRIS can perform any transformations when the message arrives, when we consume them, and if you want us to perform any additional transformation when IRIS publish the message, right? So for your other data, other system to consume. Now let's take a look at the pros and cons of this modern message-based CDCs. So I already told you message payload is very flexible. So that means you can put anything there. But that's also, that's why IRIS is such a good fit, because IRIS fundamentally is a key value store. So we're also very flexible. So if you give us flexible payloads, we're going to take it as it is. That's why we give you the performance, right? But then we also can give you, you can do transformations. We can do that for you. And because of the nature of messaging, it's by design, it's one-to-many, all right? The SQL-based CDC by design is one-to-one, although some vendor can give you one-to-many. But the messaging-based CDC by design is one-to-many. You just publish it, and then whoever subscribes can decide whether or not they want to consume that change or not. So only consume what is needed. And also, messaging-based CDC is also near real time. Nowadays, the modern messaging bus is very responsive and very fast, so you get a near real time change data capture. The cons of the message and event-based CDC is typically, as I said, because the payload is so flexible, so you must do a transformation. It's not if, or it's you must. So you need additional coding to do the transformation in order to consume and publish message, right? And the other thing is, it's so flexible. You do additional coding, we don't have a IRIS Kafka Connect yet, which our product management is on our product management roadmap. And towards the end of this session, I have a link, and then you can send your inquiry directly to our product manager and about Kafka Connect or anything related to the CDC. And the reason why we don't have it is because this approach is not as mature as the SQL-based approach, right? So it's not mature yet. Even I would argue, if you look at Kafka, Confluence Kafka is better than AWS Kafka. So as you can see, they're not mature. So the vendors, they still invest, the open source community is still investing in Kafka to make it more mature. So that's the keep in the back of your mind, is the limit of the message and event-based CDCs. Now let's talk about the last category of the CDC, is the batch-oriented CDCs. So we actually been doing this batch-oriented CDCs for ages, since the days of mainframe. At that time, that's the only way. They just dump you a fixed length record in flat files. That's how you exchange data between two mainframes, or between mainframe and mini computers. So the flat file been exists forever. Then, since we talk about that there's certain ETL needs, among other things, so the direct SQL-based replication is not sufficient. You want to do sophisticated ETLs. So many of the ETL tools, including Informatica, give you these ETL batch process. So you can take a batch files, then apply ETL rules, and then upload to your target system. IRIS fully participate that. And but nowadays there's a new tools, right? So there's a Spark, such as AWS Glue is I think Spark 2.1, and so you can use Spark to do these batch process. The key difference between Spark and versus other approaches that it basically Spark has so-called partition. So once it load the data into the Spark clusters, you can create whatever from 100 to 1,000 partitions, and each partition will load its data to its target in parallel, independently. So that will gain the speed. And we also, IRIS has its own batch loading tool called JLoader, right? So we help you. You can do the JLoaders with IRIS too. But here I want to highlight both. Many of my customers, including on AWS, they use AWS Glue, which is Spark, to interact with IRIS. But the beauty of the Spark with IRIS is that IRIS has this interoperability. So we have a very efficient Spark connectors. Underneath our Spark connector is our very efficient JDBC driver, which our JLoader also use. So basically they share the same DNA. So when you use on AWS, use AWS Glue to interact with IRIS, so you can build these Spark partitions and load your flat file into the Spark cluster in these, let's say, 500 partitions. But inside the Spark, it's called IRIS Spark Connector. IRIS Spark Connector called IRIS JDBC driver, which we are going to basically open these 500 connections for you automatically and doing these batch load in parallel. Now you realize that my JLoader has the same benefit as your Spark or AWS Glue, because JLoader uses the same JDBC driver, so it actually automatically parallelizes your load, batch load. So that's how IRIS can even help you, even in the old-fashioned batch-oriented CDCs. So now let's take a look at the pros and cons of the batch-oriented CDCs. So the pros is well established, and then typically, yeah, you can do transformations in your batch load, and it's very easy to dump your change data into your batch file. And typically, in order to capture change data, you have to use some of the technique I mentioned earlier on. Either use timestamp or use trigger, and you can dump these data to flat files. Then on the receiving end, it's very easy to load these batch files.
with the tools, or with your ETL tools, or with Spark, AWS Glue, or with IRIS JLoader. So the cons is very obvious. First, it's no real time. There's batch oriented, typically end of the day or maybe a few times a day. Then the other thing I want to highlight is probably even not change data. Because if you're talking about mainframe or old system, they even cannot do the timestamp scan nor the triggers. They don't have such thing. So all they can do is, at the end of the day, they just dump the whole entire data set. So you are really not a change data capture. You are a entire data capture. So it's EDC versus CDC. That's the keep back of your mind. So it's not that's one of the limit, I would argue, with batch-oriented CDCs. So this almost concludes my talk, but I just want to recap. So the takeaway of this, how to use IRIS to meet your CDC challenges, that yes, we can participate in your SQL-based CDC. It's very easy to use. Just plug in IRIS JDBC, ODBC driver with your replication software, and also plug in your third-party other database drivers to IRIS SQL gateway. Then you're done. Plus timestamp scan and triggers, but these are normal operations, so easy to use SQL. But the modern approach is this message event-based CDC. It is very flexible, and by design, it's one-to-many. It's very efficient, so you only consume what you need, not like the whole data set. So that's the message-based CDC. And plus, some of the challenges that the SQL-based CDC lacking, such as the very rigid SQL schema, both schema need to be same. The message-based CDCs actually allowed you to track the schema evolution, track the metadata via some like arrows on top of Kafka, so you can track what changed even in your JSON payload. So these are things very modern with the message-based, event-based CDC. But don't forget, you still have the old batch-oriented CDCs. It's that well established, it's easy to use, but there's also new spin, as I told you. And now you have all of a sudden, besides the Informatica ETL batch, now you can use Spark to load a massive amount of data into IRIS cluster very efficiently. And we also offer you our own JLoader. But as a matter of fact, we are actually moving many of the, or maybe all the features of our standalone JLoader into our underlying this powerful JDBC driver. So now later on, you may not need the JLoader jar file at all. Just use our IRIS JDBC driver jar file. Your Java application, Java developers can just invoke these batch APIs, and then you can load batch files. So that's basically the takeaways, how IRIS can help you to handle, at least overcome some of the CDC challenges. Maybe not all of them, because this is not a silver bullet. I'm not selling a silver bullet, but I just want to highlight how we can help you to meet your CDC challenges in these different categories. So that concludes my talk. But I just want to highlight, you have my contact info here, but I want you to introduce Bob to you. Bob is our product manager. I think CDC is also in one under his management. So we encourage you to reach out to me, and actually I encourage you to reach out to Bob if you have any questions or inquiries or requirement related to CDC. Bob wants to hear from you, so please send Bob, drop Bob a note if you have any questions. So that concludes my talk, and I want to say thank you. Stay safe. I will see you next year at a global summit, and so hopefully we'll meet face to face. Thank you. Goodbye.